Hello, curious minds. Imagine a world shrouded in golden haze, where rivers of liquid methane flow under an orange sky, and where humanity might one day call home. Could we transform Saturn's mysterious moon Titan into a thriving second Earth? Let's dive into this challenge. So, why Titan? Why pick this frigid moon orbiting a gas giant as a potential future home for humanity? First, Titan is unique. It's the only moon in our solar system with a thick atmosphere. In fact, its atmosphere is so dense that it's thicker than Earth's. This gives Titan a surprising edge. It provides some protection against radiation, something few other moons or planets can claim. Second, Titan has an abundance of liquid. We're talking lakes and seas, but instead of water, they're filled with liquid methane. Imagine that. Methane rain, methane rivers, methane oceans. Now I know what you're thinking. Methane isn't exactly ideal for swimming unless you have a thing for really cold showers. But here's the thing. This methane is a potential gold mine, literally. It could serve as a resource for energy or fuel, giving us a head start in building a sustainable presence. Strangely enough, Titan also shares some eerie similarities with early Earth. Its thick nitrogen atmosphere and organic-rich surface remind scientists of what our planet may have looked like billions of years ago. Could it hold secrets to how life began? It's like Titan is this giant chemistry lab. And here's an intriguing twist. In the distant future, when our sun becomes a red giant, Titan could naturally shift into the Goldilocks zone. The increased warmth from the sun could thaw Titan's icy surface, potentially creating oceans and a more Earth-like environment. While this is billions of years away, it adds another layer of fascination to Titan's story. So, with its dense atmosphere, abundant resources, and scientific intrigue, Titan offers an incredible opportunity to test the limits of human ingenuity. But how do we tackle the enormous challenges of turning this alien world into a second home? Let's explore. Okay, so we've got this moon with a thick atmosphere, liquid methane, and maybe even some organic molecules. Sounds promising, right? But hold your horses, because terraforming Titan is not going to be a walk in the park. Let's dive into the challenges we'd face. First and foremost, we've got the temperature. Titan is really cold. We're talking about an average surface temperature of minus 179 degrees Celsius, or minus 290 degrees Fahrenheit. This environment makes Antarctica feel like a tropical paradise. So, we're going to need to find a way to warm this place up significantly if we're ever going to grow anything besides ice crystals. This would demand colossal amounts of energy, far beyond anything humanity has achieved today. Then there's the issue of sunlight, or the lack of it. Titan receives about 1% of the sunlight that Earth does, which means it's perpetually stuck in a state of semi-darkness. Not exactly ideal for growing crops or powering solar panels. Serious innovations in artificial lighting and energy storage, like nuclear reactors or fusion power, would be essential to sustain life or even begin terraforming. And of course, we can't forget about that atmosphere. While it's great for protection, it's not exactly breathable for us. So we need to figure out a way to convert that nitrogen and methane into something a little more, shall we say, human-friendly. But here's a twist. Breathing on Titan isn't just impossible. Introducing oxygen could create an explosive mix with methane, presenting serious safety risks. Solving this would require advanced life support systems or atmospheric processors to convert methane into safer compounds and generate oxygen. Then there's the surface itself. Titan's rivers and lakes are filled with liquid methane and ethane. They'd need to be replaced with liquid water if we ever want to grow crops or build a sustainable ecosystem. And what about gravity? People living on Titan could walk around, or rather, bounce around, since the gravity is 14% of Earth's gravity, which is just a little less than the gravity on the moon. While this might sound fun, the low gravity poses serious challenges for long-term human health, including muscle and bone degradation. Another critical challenge is the lack of a magnetic field. While Titan doesn't have its own magnetic field, it does benefit from being within Saturn's vast magnetosphere. This magnetic field helps protect Titan's atmosphere from the worst effects of solar radiation and cosmic rays, though it's not as powerful or localized as Earth's magnetic field. While the magnetosphere offers some defense, Titan is still exposed to a certain degree of radiation, which could present challenges for long-term colonization or terraforming efforts. And if those challenges weren't daunting enough, there's the small matter of distance. Titan is about 1.2 billion kilometers or 746 million miles away from Earth. That's a long commute, even for the most dedicated space traveler. It would take years to get there with our current technology, and that's assuming everything goes according to plan. And as we all know, in space exploration, things rarely go according to plan. Unforeseen challenges and risks are part of the journey. But hey, challenges are what make life interesting, right? And who knows, maybe by the time we develop the technology to terraform Titan, we'll have figured out faster than light travel too. So how do we even begin to tackle this project? It's a colossal challenge that requires innovative thinking and cutting-edge technology. Well, the first step is to warm things up, literally. One idea is to use giant orbital mirrors to reflect more sunlight onto the surface. These mirrors could gradually raise temperatures, melting some of Titan's frozen water and altering its atmosphere. The engineering challenges are immense, but not insurmountable. Alternatively, we could use nuclear or fusion energy to generate heat directly. These power sources might also drive machines that release greenhouse gases, kickstarting a warming process similar to what's happening unintentionally on Earth. We also need to create a breathable atmosphere. One idea is to use genetically engineered microorganisms that can convert Titan's methane and nitrogen into oxygen. These microorganisms would act as tiny factories, slowly transforming the atmosphere. This process could take centuries, even millennia, to complete. Patience and persistence will be essential. But hey, Rome wasn't built in a day, and neither is a habitable moon. Another approach might involve advanced atmospheric processors like giant versions of carbon scrubbers on Earth. They could convert methane into carbon dioxide and eventually into breathable air. To establish ecosystems, we'd need to replace Titan's methane lakes and rivers with liquid water. This could involve importing ice-rich asteroids or using energy from fusion plants to melt existing subsurface water ice. Over time, Titan's surface could resemble Earth's. But what about gravity? One possible solution is artificial gravity, using spinning habitats or centrifugal force to mimic Earth-like conditions. While this wouldn't terraform Titan itself, it could make life there more sustainable. And let's not forget Titan's lack of a magnetic field. Without it, solar radiation could strip away any newly formed atmosphere over time. A large-scale magnetic shield, positioned between Titan and the Sun, could provide protection, ensuring that the atmosphere we create stays intact. Terraforming Titan would require an unprecedented level of scientific ingenuity and cooperation. But with advanced technologies, these strategies show that transforming an alien world isn't entirely beyond our reach. The question is, will humanity rise to the challenge? Okay, so we've established that terraforming Titan would be a monumental undertaking, fraught with challenges and uncertainties. And why go through all the effort? Let's explore the potential benefits. First and foremost, Titan represents a chance for humanity to expand beyond Earth. With a population approaching 10 billion and Earth's resources stretched thin, having another habitable world could relieve pressure and offer new opportunities for exploration and settlement. It could serve as a crucial stepping stone in humanity's broader space exploration efforts. Its distance from Earth makes it an ideal candidate for developing technologies and systems needed for long-term space travel. Even in its current state, Titan is a treasure trove of natural resources. Its vast lakes of methane and ethane, along with frozen water and other organic materials, could support human industries and fuel interplanetary travel. Terraforming Titan would drive unparalleled scientific advancements. From understanding atmospheric chemistry to developing bioengineered organisms, the technologies and knowledge gained could revolutionize fields like climate science, renewable energy, and even medicine. Terraforming Titan also offers humanity an insurance policy, a Plan B. If Earth were to face a catastrophic event like an asteroid impact, nuclear war, runaway climate change, or even the distant threat of the Sun entering its red giant phase, having a habitable Titan could ensure the survival of our species. Perhaps one of the greatest benefits is the inspiration it provides. A project of this magnitude could unite nations, fostering global cooperation and a sense of shared purpose. Imagine what humanity could achieve when working together to transform an alien moon into a thriving new world. From providing a new home to unlocking groundbreaking technologies, the benefits of terraforming Titan are as vast as the challenges. The question isn't just whether we can do it, but whether we dare to dream big enough to try. Now you might be thinking, this all sounds great, but is anyone even working on this stuff? And the answer is, you bet they are. While terraforming Titan is still far from reality, current research and projects are laying the groundwork for what could one day be possible. Let's take a look at some of the most promising developments in space exploration and planetary science that are taking us one step closer to this ambitious goal. NASA, the European Space Agency, and other space agencies around the world are actively studying Titan and developing the technologies that could one day make terraforming a reality. NASA's Cassini mission, which ended in 2017, provided invaluable data about Titan's atmosphere, weather patterns, and surface conditions. One of its most important discoveries was the presence of liquid methane lakes on Titan's surface, which raised the possibility of using them as resources for future colonization. Currently, NASA's Dragonfly mission is set to launch in the 2030s. This rotorcraft will fly across Titan's surface, studying its chemistry, geology, and potential for life. Meanwhile, the European Space Agency is also eyeing Titan for future exploration. Their missions focus on gaining a deeper understanding of Titan's atmosphere and surface, which will be crucial for planning long-term human habitation. Private companies are also getting in on the action. SpaceX, for example, with its sights set on Mars, is developing reusable rockets and spacecraft that could significantly reduce the cost of space travel, making missions to Titan and beyond more feasible. And then there are the countless research projects happening right now in labs around the world, from developing new materials that can withstand Titan's extreme conditions to genetically engineering microorganisms that could thrive in its alien environment. Plus, its thick, nitrogen-rich environment is similar to early Earth's, providing a unique opportunity to learn about atmospheric evolution. Understanding how Titan's atmosphere functions and how it could be altered is key to any terraforming efforts. To terraform Titan, we'll need immense energy resources. That's why researchers are making great strides in developing more efficient power sources, like nuclear fusion and advanced solar technologies. Fusion power, in particular, could be the key to generating the energy required to alter Titan's atmosphere and generate the heat needed for life-supporting conditions. Another exciting area of research is artificial gravity. Scientists are experimenting with rotating habitats that could mimic Earth's gravity using centrifugal force. Space habitat designers are also working on creating sustainable, self-sufficient habitats for Titan. These habitats would need to protect inhabitants from radiation, provide life support systems, and create Earth-like conditions in the harsh environment of Titan. The integration of 3D printing, advanced materials, and AI for autonomous operations is already being explored to make these habitats a reality. While we're still in the early stages, these ongoing projects and research efforts are helping to build the foundation for what could one day become humanity's next home. And who knows, maybe one day some of you watching this video will be the ones designing the habitats, building the robots, or even planting the first trees on a terraformed Titan. So, after all that, the big question remains, will terraforming Titan ever become a reality? Well, if you ask us, in the vast timescale, anything is possible. If we humans can dream it, we can engineer it. But it's going to take time. A lot of time. It's going to require a level of global cooperation, technological innovation, and financial investment that we haven't seen before. But hey, humanity has a knack for surprising itself. Just look at how far we've come in the last century, from the first airplane to landing on the moon. Who could have imagined that 100 years ago? So while terraforming Titan might seem like science fiction today, who knows what the future holds? It all starts with you and me, with curiosity and imagination, and of course with a willingness to ask big questions and dream even bigger dreams. Because the future belongs to those who dare to explore the unknown. And there you have it. Terraforming Titan is one of humanity's most ambitious dreams, full of challenges, possibilities, and mysteries. But what do you think? Could we ever overcome the freezing temperatures, the lack of sunlight, and Titan's alien atmosphere to make it habitable? Or is this a vision best left to science fiction? Let us know your thoughts in the comments below. If you enjoyed this cosmic adventure, don't forget to like, subscribe, and hit the bell icon so you never miss a journey into the wonders of the universe. Thanks for watching. Until next time, keep looking up.